So looking at the rest of these calculations, you can see that, as we calculate the y value, we can use this new x and y value to calculate a new slope here. So I get a new slope of 2.2. And I use that slope in the equation to generate my new linear equation. And then I plug in the next x coordinate, okay, to estimate the next y coordinate. In this case, it's going to be 1.42. Okay, we use those two coordinates again to calculate a new slope. Okay, there's my new slope formula. There's my linear equation formula. And again, I can just plug in and end up with 1.662. So that's how I fill out my table here. Just a note here that this term here is essentially your delta x. So you don't have to rewrite that in every time if you recognize that. So using the solution, the exact solution to this differential equation, we get these values here. And you can see that the discrepancy is actually quite low between the approximation, Euler's approximation, versus the actual solution to that differential equation. Okay, so, and again, if you want to just pause, you can just take a look at these are the calculations that get me to that allow me to fill out the left side of that table. Okay, the right side of that table for this side is calculated using that equation. Okay, so we can, once you've checked that over, you can try this one. I'll do the first couple steps with you. So here we want to use the Euler's method. There's my derivative. Okay, so I want to use that to calculate my slope. Here's my starting position. At x is 0, y is 1. And I'm going to use a delta x of 0.4. Okay, so my starting position is x is 0, y is 1. I'm going to use those x and y's, so 0 minus 1, to generate my slope. Okay, so there's my slope. So once I have my slope and I have my point, I can generate my linear equation formula. So my equation is going to look like this. Y is equal to my slope. Okay, it's going to be x minus 0 plus 1. Okay, so there is my equation to calculate my next coordinate. So my next coordinate is going to be at 0.4. X is equal to 0.4. Okay, so the y value at 0.4. Okay, when I plug it into this equation, I'm going to get negative 0.4 plus 1. So that's going to be 0.6, it looks like. Okay, so there's my next coordinate. 0.6 is my next coordinate. And then once I calculate that coordinate, I'm going to use the derivative to now calculate the slope for the next iteration of this. So 0.4 minus 0.6 is going to give me a slope of 0.2. Okay, so then I go to my next iteration of this. Okay, so I'm going to repeat this process. Now I have the slope. I can write my new equation. So I'm going to find out the y value at 0.8. Okay, so y value at 0.8. Okay, my slope is going to be negative 0.2. Okay, my delta x is 0.4. Okay, so that's going to be the difference between my new coordinate and my old coordinate. Okay, so that's going to be that part there. And then plus my old y coordinate. Okay, so this is going to be my linear approximation. This will give me the y coordinate at 0.8. So when I plug this in, okay, using my calculator here, I'm going to go negative 0.2 times 0.4 plus 0.6. Okay, so I get a y coordinate of 0.52. Okay, so there's my second approximation point. Now then again, I do repeat the process. I'm going to use this approximation point. So y of 0.8 is equal to 0.52. So I'm going to use this x and y coordinate in my derivative to calculate a new slope. So 0.8 minus 0.52. Okay, getting my slope now, I get 0.28. Okay, so it looks like it's positive. Just want to double check this. Negative 0.04. Yeah, it's going to give me 0.52. My x coordinate, so x minus. So I'm going to end up now with a positive slope. So I'm going to end up with positive 0.28. Okay, so there's my new slope. And then allows me to get my third iteration of this. So y lets me calculate the next coordinate at 1.2. So y of 1.2. Again, it is important to be able to keep organized in how you calculate this information. A table is really important. Okay, to make sure that you've organized this work, make sure you can keep track of which stage you're on. Okay, don't mix up your slope with which layer your slope goes with. So my slope here goes with this coordinate. Okay, so I'm going to end up with 0.28 positive as my new slope. The difference between the two x coordinates is going to be my delta x, or 0.4, plus 0.6. Okay, so there's my, oops, sorry, not 0.6. I have to plug in. This is what I mean about keeping track of things. Make sure that you know the right parts here. So I'm going to be at my new y coordinate of 0.52. Okay, so then just being careful with my calculation, double checking I've got it all straight. 0.28 times 0.4 plus 0.52. Okay, so I'm at 0.632. 0.632. Okay, so that's my new y coordinate, 0.632. Okay, so then I'm going to use those two coordinates to calculate my new slope. 1.2 minus 0.632. Okay, my new slope is going to be 0.568. Okay, so there's my new slope. I'm going to use that new slope to calculate my next iteration at 1.6. So I have a couple more iterations to go here. Okay, so I need to calculate for those two still. Okay, so my fourth iteration here is going to be y of 1.6 is equal to, okay, my slope value. So I need to calculate my new slope. My coordinate is going to be 1.2, 6.2. So I've calculated my new slope is going to be 0.568. And again, make sure you're keeping this organized. You know which parts go with which. Okay, 0.4 is my difference between these two coordinates, plus, okay, my coordinate that I'm extrapolating for, or my estimating from, the coordinate of 1.6.632. Sorry, 1.2.632. Okay, so there's going to be my next extrapolation, my next estimation. So again, I need to use my calculator for this. These numbers are starting to get a little bit difficult to work with. So plus 0.632. Okay. So I end up with 0.8592. 0.8592. And so this will be my last iteration here. So y 1.6, I get 0.8592. Okay, and then I need a slope to come up with my new point. Okay, so my slope is going to be 1.6 minus 0.8592, so 0.7408. Okay, so then my new equation looks like this. When I'm calculating, I'm going to use that slope for this point at x equals 2.0. So my equation is 0.7408 times x minus x1, so it's going to be again 0.4, plus, and it's going to extract, I'm going to estimate from this last point, y coordinate of 0.8592. Okay, so this is my last calculation for the last coordinate, times 0.4 plus 0.8592. I'm going to get a final position of 1.15552. Okay, so there it is. There's my approximation. So I've used delta x. This is like actually quite a big delta x, but I've started at 0 and 1, and I've done a few iterations here to get my new coordinate at 2 and 1.15, about 1.16. Okay, so the next video will just show you what the graph of that looks like and how it kind of follows slope fields. And essentially, we're just building slope pieces to make this graph to estimate coordinates along the curve.